170 tons. That's how much irradiated uranium is still sitting in the basement of Chernobyl's Unit 4. Right now. Not in 1986. Now. 95% of the original fuel never left the building. It melted through the floor, pooled in the rooms below, and hardened into something resembling volcanic rock. And it's still there. I think most people assume Chernobyl is finished. HBO made a show. Tourists took selfies next to the Ferris wheel. Someone built a 1.5 billion euro steel arch over the ruins, and the world collectively exhaled. Problem solved. Move on. But the reactor didn't move on. In 2021, Ukrainian scientists at the Institute for Safety Problems of Nuclear Power Plants noticed something that should have made headlines everywhere but barely registered. Sensors were picking up a steady rise in neutron emissions from deep inside the destroyed reactor hull. Neutrons are the signature of fission, atoms splitting, releasing energy. The kind of thing that's supposed to happen inside a working reactor, not inside a ruin that's been contained for nearly 4 decades. The readings were coming from an inaccessible room buried under tons of rubble. Room 305/2. Nobody can get in. The radiation levels are too high for humans, and every robot they've ever sent into similar areas has had its electronics fried within minutes. Maxim Savelyev, a senior researcher at the Institute in Kiev, put it as carefully as a scientist can. We can't rule out the possibility of an accident. Neil Hyatt, a nuclear materials chemist at the University of Sheffield, was more vivid. He said it's like the embers in a barbecue pit, smoldering, not dead, not safe, just waiting. The neutron count in that room nearly doubled over 4 years, and it's still climbing. We tell ourselves we defeated Chernobyl. We built a tomb and walked away. But something inside that tomb has a pulse. And to understand why it's waking up, you need to understand what the reactor core turned into the night it melted down. A substance so strange they had to invent a name for it. Corium. That's the name. You won't find it in any periodic table because it's not an element. It's a mistake. A substance that only exists when a nuclear reactor fails so catastrophically that everything inside melts together into something new. It's only been created accidentally 5 times in human history. Once at 3 Mile Island, 3 times at Fukushima, and once at Chernobyl, where it formed on a scale nobody had seen before or since. I spent a long time studying what happened in the hours after the explosion. The fuel didn't just melt. It liquefied at temperatures exceeding 2,600 degrees Celsius. That's hot enough to devour steel. Hot enough to eat through reinforced concrete like acid through paper. The molten uranium mixed with zirconium cladding from the fuel rods, graphite from the control rods, sand that helicopters had dumped from above, and the concrete itself as the lava, chewed through floor after floor. This boiling cocktail flowed through pipes, corridors, and cable channels, pooling wherever gravity took it. The most famous formation settled in Cable Corridor 217/2. A 2-ton black mass, wrinkled and bulging, that the first men to find it nicknamed the elephant's foot. When they measured it in those early months, the readings were clear. 5 minutes in its presence, and you were dead. They couldn't get close enough to study it. They pushed cameras around corners on wheeled carts, and when they finally needed a sample, no drill could penetrate it. No robot could survive long enough. So someone fired armor-piercing rounds from an AK-47 to chip off a piece. That's how hard it was. But here's what should keep you up at night. By 1998, the elephant's foot started cracking. The outer layers began turning to powder. By 2021, researchers described its consistency as similar to sand. The most indestructible radioactive mass on the planet is disintegrating on its own, not into something safe, but into fine, breathable, uranium-laced dust. And the elephant's foot is only one formation. The real danger is in a room nobody can enter. Room 305/2. And something in there is waking up. Room 305/2 sits directly beneath where the reactor core used to be. It was the first place the corium pooled after it melted through the floor. By the best estimates available, this single room contains roughly half of Unit 4's original fuel load. Over 60 metric tons of irradiated uranium, buried under a chaos of collapsed concrete, twisted steel, and hardened lava flows. For decades, this room behaved itself. The readings were stable, sometimes even declining. And there was a simple reason: rain. The original sarcophagus, that hastily built concrete shell from 1986, was riddled with cracks and gaps. Rain poured in. Birds flew through holes in the roof. It was a miserable piece of engineering. But that water seeping into room 305/2 was doing something crucial. It was moderating the neutrons, slowing them down, absorbing them before they could strike uranium atoms and trigger fission. The leaks were an accidental safety system that nobody had designed. Then, in November 2016, they slid the new safe confinement into place. A 1.5 billion euro steel arch, the largest movable land-based structure ever built. Hermetically sealed. No more rain, no more birds. The world celebrated, and the neutron counts in room 305/2 started climbing. I've read the ISPNPP reports. Ukrainian scientists had actually predicted this before the arch was even finished. They published papers, presented at conferences. Remove the rain and the fuel dries out. And drying fuel in this specific configuration doesn't become safer. It enters a zone physicists would rather not think about. Too much water drowns the reaction. Too little, and neutrons fly too fast for uranium to capture them. But somewhere in between is a sweet spot where conditions are just right for fission to accelerate exponentially. Room 305/2 might be drifting into that sweet spot right now. And here's the paralysis. Radiation levels inside are so extreme that no human can enter, no sensor can be installed, and the fuel-containing material is entombed under meters of concrete that make gadolinium nitrate spraying, the standard neutron suppression method used in other rooms, physically impossible. Let me give you a piece of arithmetic that should ruin your afternoon. Plutonium. 239 has a half-life of 24,100 years. The original sarcophagus was designed to last 30. The new safe confinement was designed for 100. That's our best effort. A century of shelter for a problem that outlasts recorded civilization by a factor of 5. And we couldn't even manage the century. On February 14th, 2025 at 1:50 in the morning, a Russian Chernobyl drone, a modified Iranian Shahed, the kind that costs maybe $30,000, punched through the roof of the new safe confinement, the structure that 40 countries paid 2.15 billion euros to build, the largest movable land-based structure ever assembled on Earth, punctured by a weapon cheaper than a mid-range sedan. The fires burned for 3 weeks. Greenpeace sent a team in March and reported that 50% of the north roof structure had been severely damaged, along with sections of the south roof and side walls. By December 2025, the IAEA made it official. The new safe confinement had lost its primary safety functions, including confinement capability. The thing built to confine could no longer confine. And inside this compromised shell sits the original sarcophagus, which has been rotting for 4 decades. I've looked at the structural assessments. The western wall is cracked. The internal steel is corroding from decades of humidity. The mammoth beam supporting the roof rests partly on walls damaged in the original explosion, and the upper biological shield, a concrete slab weighing roughly 2,000 tons that was blown upward in 1986, still rests at a 15-degree angle, wedged between walls, held in place by geometry and hope. The deadline to dismantle the most unstable parts has already been pushed from 2023 to 2029. Before the war, before the drone, Before the IAEA declaration, we've spent 4 decades building containers for this problem, each one a little bigger, a little more expensive, each one temporary. Concrete crumbles, steel corrodes, wars happen. But even without the drone, even without the war, there's a deeper problem, one that no amount of engineering can solve. Suppose we solve room 305/2. Suppose we fix the arch, extract all 170 tons of uranium, and seal it somewhere deep underground. Then what? Then we need to make sure nobody digs it up. Not next year. Not next century. For 10,000 years at minimum. Probably longer. Think about that timescale. 10,000 years ago, humans hadn't invented writing. The oldest texts we can still read are about 5,000 years old, and scholars still argue about what they say. Every language on Earth right now will be unrecognizable in a fraction of that time. English is already incomprehensible past about 6 centuries. In 1981, the U.S. Department of Energy realized it had a problem beyond physics. It assembled a team, linguists, anthropologists, nuclear physicists, behavioral scientists, and gave them the most surreal assignment in the history of government work: design a warning system that functions for 10,000 years. They called themselves the Human Interference Task Force, and the ideas they produced sound like science fiction. Except, they're deadly serious. Semiotician Thomas Sebeok proposed an atomic priesthood, a self-perpetuating religious order, like the Catholic Church, but for radiation, passing down forbidden knowledge through rituals and mythology across centuries. Sandia National Laboratories designed fields of enormous black concrete spikes, arranged to feel instinctively hostile, a landscape that screams danger in a language older than words. The most poetic proposal came from writer Françoise Bastide: breed cats that change color when exposed to radiation, then embed the legend of these ray cats so deep into human folklore that the warning survives the death of every civilization that told it. None of these solutions have been tested. The radiation trefoil, that yellow and black symbol we consider universal, is recognized by roughly 6% of the world's population. Japan erected tsunami warning stones for centuries. Later generations built houses directly below them. Finland's solution for its onconuclear repository is the simplest: bury it, leave no markings whatsoever, and hope nobody digs there. That's the best we've got. But before we worry about the year 12,000, there's a question we need to answer right now. Who's paying for this? The Chernobyl Shelter Fund collected over 1.6 billion euros from 45 donor countries across 2 decades of international cooperation. It was closed in 2020. Its replacement, the International Chernobyl Cooperation Account, had received roughly 14 million euros from 18 countries by mid-2024. Read those numbers again. The old fund, 1.6 billion. The new one, 14 million. That's not a continuation. That's a rounding error. And the bills are mounting. Repairing the drone damage alone could cost several hundred million euros. The EBRD has pledged financial support for 2026, but the engineering assessments haven't even determined whether the original NSC design can be replicated or whether the structure's lifespan has been permanently shortened. Meanwhile, the 4-stage decommissioning plan, reactors deactivated by 2025, maintained until radiation drops by 2045, site fully cleared by 2065, was drafted in a world that no longer exists. Before the invasion, before the occupation, before Russian soldiers drove armored vehicles through the Red Forest, and a drone hit the arch at 2 in the morning, Ukraine can barely keep its electricity grid functioning under constant bombardment. Since independence, Chernobyl benefits have been a crushing fiscal weight. The number of registered disabled grew from 200 in 1991 to over 91,000 by 2001, and every attempt to restructure the system ran into political walls. This is a country being asked to manage the most complex nuclear decommissioning on Earth while fighting for its survival. The international community built something extraordinary at Chernobyl. 40 countries cooperating across decades to contain a Soviet-era catastrophe. But extraordinary things require extraordinary commitment. And commitment has a shelf life that isotopes don't. Cesium-137 doesn't care about elections. Strontium-90 doesn't care about donor fatigue. And plutonium-239, sitting in the basements beneath that damaged arch, will be dangerous for 24,100 years. The longest surviving human institution, pick whichever one you like, is maybe 1,500 years old. The reactor isn't finished with us. The question is whether we'll finish with it first.